Hi, and welcome to the video on further exponential growth. In a certain town, the growth rate of a population is given by dn dt equals k outside of n minus 125, where n is the population and t is the time in years. Question A asks us to show that n equals 125 plus ae to the kt is a solution of the differential equation. Now, because we're asked to show that this expression is the same as the one in our question, we can actually begin with the expression n equals 125 plus ae to the kt and rearrange it to make it look like the one in our question. Now, because the one in our question is a rate and it has been differentiated, I'm going to differentiate both sides of my expression to get dn dt equals ka e to the kt. Next up, I can see from my question that dn dt is the same as in my question, the k is the same as in my question. I just need to show that ae to the kt is the same as the bracket n minus 125. So what I'm going to do with that part of the expression that's inside the circle is I'm going to rewrite it using some 125s. But in order to do that, I need to add and subtract the same 125. You see, if I add 125 and subtract 125, I haven't actually changed the expression at all, with the exception of what it looks like. Because this 125 plus ae to the kt is the same as n, I can now rewrite that as dn dt equals k outside of n minus 125, which is exactly what my expression I'm trying to show it looks like. So therefore, n equals 125 plus ae to the kt is a solution of the equation. Part B says if the population is initially 25,650 and after 5 years it is 31,100, we want to know what the population will be after 8 years. So we want to know what n is when t equals 8. So I begin with my expression from part A, n equals 125 plus ae to the kt, and I'd love to be able to substitute t equals 8 into that expression, but I have two other variables, a and k, so I need to work those out first. I know from my question that initially when t is 0, the population is 25,650. So I'm going to sub that into my expression. What you'll see is that we get a part of the expression e to the k times 0. In this case it's e to the 0, which is 1. So I have 25,650 equals 125 plus a. So if I subtract 125 from both sides, I get an expression for a. Substituting that in, I know that n is 125 plus 25,525 e to the kt. Now I'm going to use my second part of my question, the fact that in 5 years' time the population will be 31,100, and I'm going to substitute that into my expression to get a value of k. So what I'm going to do now is show the expression when I've substituted in t equals 5 and n equals 31,100. I have one variable, k, and that's what I'm going to work out. So I subtract 125 from both sides, and I divide both sides by 25,525 to get the simplified fraction of 1239 over 1021 equals e to the 5k. I now take the natural log of both sides to give me an expression for 5k, and I divide both sides by 5, giving me an answer of log 1239 over 1021 divided by 5. What I'm going to do is I'm going to say that that's approximately equal to 0.0387, so that when I do some more further calculations and further working out, I don't want to have to write that large fraction into my working out. So moving my working over to the left hand side now, what I'm going to do is I'm going to substitute in all the variables that I know into my expression. So n is going to be 125 plus 25,525 e to the 0.0387 t. At this point, I can now substitute t equals 8 and work out what the population is going to be. So when I substitute in all those variables and I substitute t equals 8 in, I want to make sure that I have the most accurate answer possible. So instead of putting 0.0387 into my calculator, I'm going to begin by putting log 1239 over 1021 divided by 5 in and getting it as my answer in my calculator. This way, when I go to find the most accurate answer, I can put in 125 plus 25,525 e to my answer times 8. It's not going to make a huge difference to the final answer, but it is good practice. And we get a final value for the population after 8 years of 34,912.73633. Rounding this off to a whole number, You could make a case that the population will be 34,912 because you can't have zero point 0.7 of a person. That makes sense contextually. But what I would say is we're going to use the rules for rounding off to get the answer that the population after 8 years will be 34,913. Part C now asks us, when will the population reach 40,000? This is important in a real world context because once you get to a certain threshold of the population, you're going to need more services, more parks, more schools, more police, more fire engines. So for planning purposes, this is a very important mathematical question. We have the expression from parts A and B that n is 125 plus 25, 525 e to the kt. Remembering that k is this big fraction, which we're going to substitute in 0.0387 as a placeholder while we do our calculations. We want to know when will the population be 40,000, so we're going to sub n equals 40,000 into our expression. Subtracting 125 from both sides, I get 39,875 equals 25,525 e to the 0.0387t. Remember, it's just a placeholder. I'm going to divide both sides by 25,525 to get the simplified fraction 1595 over 1021. I'm then going to take the natural log of both sides and divide both sides of my expression by 0.0387. Again, remembering that k, the 0.0387, actually has a much more accurate answer from your calculator. So at this point, I think we should put this into our calculator and get it as our answer, because we're going to need to substitute this value for the value for the k into our expression now. The most accurate answer we can get with our calculator is going to be 11.52559013. Now, we want to know what our answer is to three significant figures. So to three significant figures, it will take 11.5 years to reach a population of 40,000. I hope this video has helped you work out questions with further exponential growth. As always, check your text for further information and good luck.